Hi students, we are studying the theory which is required for exercise 2.5. We have learned nature of roots depending on value of b square minus 4ac, that is delta. And now we are finding the relation between roots of the quadratic equation and the coefficients. Roots of a quadratic equation and the coefficients. Standard form of quadratic equation is a square plus bx plus c, ax square plus bx plus c is equal to 0. Coefficients a, b, c, coefficients a, b, c gives us the certain numbers. Okay, these coefficients are related with the roots. Suppose alpha and beta are the roots of given equation. Alpha and beta, we are on page number 46. We are on page number 46. So alpha and beta are the roots. Then sum of the roots is equal to alpha plus beta is equal to minus b upon c. If we take a ratio of a middle terms coefficient and first term coefficient, then we will get the value of sum of the roots and product of roots can be given alpha into beta is equal to c upon a. So we have seen the relation between the coefficients and constant term with the sum of roots and product of roots. This is very important to understand for exercise number 2.5. We have learned b square minus 4ac equal to 0, b square minus 4ac greater than 0, and b square minus 4ac less than 0 means positive and negative. These things are very important in solving our exercise 2.5. So we will start exercise 2.5 based on this. These are the relations and the nature of the roots. First example is quadratic equation ax square plus bx plus c is given. And values are given. The first value of b square minus 4ac is positive. Plus 5. b square minus 4ac is positive. And in the second column they have given, second row they have given b square minus 4ac is equal to negative. Then what are the natures of the roots? you have to fill up the natures of the root. Natures of the roots. So when it is positive, the value of b square minus 4ac, that is discrimination, that is delta, is positive, it gives real and unequal. When value of b square minus 4ac is positive, the roots will be real and unequal. And the next one is negative, minus 5. So they are unreal, yeah, not real. The roots will be not real. This is the fill in the blank activity. So it's very easy. Standard equation, roots, value of delta is positive, value of delta is negative. What will be the effect on its equation's roots? When it is positive, roots are real and unequal, and b square minus 4ac is negative, then the roots are not real. Okay, it's very easy. This is activity 2. They have given sum of the roots and product of the roots. We know any quadratic equation can be written as x square minus sum of the roots, that is alpha plus beta, and plus product of roots. In short, x square minus alpha plus beta x plus alpha into beta is equal to 0. So, sum of roots means this is alpha plus beta, and product of root means this is alpha into beta. By using these values, we can form the equation like this. So x square minus alpha plus beta, that is minus 7x, plus alpha into beta, that is 5, is equal to 0. The final answer is x square plus 7x plus 5 is equal to 0. So remember, this is the form of equation when we know the roots alpha and beta. X square minus alpha plus beta x plus alpha into beta is equal to 0. This we have used here and we got the answer. Now we are going for activity 3. So this is activity 3 of exercise 2.5. Question number 1, activity 3. They have given an equation 2x square minus 4x minus 3 is equal to 0, and they have asked us values of alpha plus beta and alpha into beta. We know alpha plus beta is equal to minus b upon a. So our b is minus 4 upon 2. Minus 4 upon 2, which is equal to 4 upon 2 is equal to 2. and alpha into beta is equal to c upon a, which is equal to minus 3 upon 2. These are the values by using the relation between roots and the coefficients. Roots and the coefficients. A is 2, B is minus 4 and C is minus 3. Using the relation between coefficients and roots. So alpha plus beta is minus 3 upon a, that is minus 4 upon 2. It is 4 upon 2, and alpha into beta is equal to c upon a, which is equal to minus 3 upon 2. This is activity 3, question number 1 of exercise 2.5. So this is question number 2. Find the values of discriminant, that is b square minus 4ac. First equation is x square plus 7x minus 1 is equal to 0. What we have to do is compare with standard equation. Comparing with ax square plus bx plus c is equal to 0. So a is equal to 1. B is equal to 7 and C is equal to minus 1. So we need now discriminant. The symbol is delta. Delta is equal to b square minus 4ac is equal to b is 7 the whole square minus 4 into bracket a is 1 into minus 1, which is equal to 49 minus into bracket 4 into minus 1, which is equal to 49 minus 4, 49 minus into bracket minus 4. So it will be 49 plus 4, which is equal to 53. We can decide the nature of roots here only. The b square minus 4ac is positive. So the roots will be real and unequal. Roots will be real and unequal. Roots will be since delta is greater than 0, roots will be real and unequal. We can check here. Same type of examples we have to solve in third question. So I am making practice of that only. Real and unequal. When delta is positive, the roots are real and unequal. Now we are in the second. Second is homework. Please do it home. It will give you good practice. So we are in the third one. Compare with ax square plus bx plus c is equal to 0. A is equal to root 2, b is equal to 4 and c is equal to 2 root 2. Yeah. This is third question of question number 2. So delta is equal to b square minus 4ac is equal to b is 4 the whole square minus 4 into bracket a is root 2 into c is 2 root 2, which is equal to 4 square is 16 minus 4 into bracket. You might have studied surds in 9th standard. Root 2 into root 2 is 2 into 2, which is equal to 16 minus 4 into 4, which is equal to 16 minus 16 is equal to 0. When delta is 0, value of delta is 0, the roots are real and equal. Real and equal. Since delta is equal to 0, roots are real and equal. Depending on these examples, you can solve question number 3. Depending on this, you can solve question number 3. If you have got any doubts, you please ask me on WhatsApp. I will solve them immediately. So this finishes question number 2, and 3 is for homework. Same, finding the value of delta. If it is positive, write the result. If it is negative, write the result. And if it is 0, write the result. That's all. Correct? Negative, not real. Positive, real and unequal. And if it is 0, real and equal. Question number 3, I have given the hint. You can solve them. Okay? So question number 3 is homework. Finding the value of a square minus 4s and deciding the types of root. So question number 3 is homework. And now we are in the question number 4. What they have written? They have written, form the quadratic equation if the roots are 0 and 4. If the roots are 0 and 4. So first is roots are 0 and 4. 0 and 4. Therefore, alpha is equal to 0 and beta is equal to 4. Two roots are given and we have to form the equation. So, first is alpha plus beta is equal to 0 plus 4 is equal to 4. And second is alpha into beta. We have to find alpha into beta. It is 0 into 4 is equal to 0. By using this and the equation using the roots is, since x square minus alpha plus beta x plus alpha into beta is equal to 0. This is the form of equation when roots are given. So roots are given and we got the value x square minus 4 into x plus alpha into beta is 0 is equal to 0. Therefore, x square minus 4x plus 0 is equal to 0. One term is missing. One term is missing. Question number 4, first example is, the required equation is final answer, required equation is x square minus 4x plus 0 is equal to 0. You must know the standard equation after by giving the roots, when the roots are given, that is x square minus alpha plus beta x plus alpha into beta. Then you can write any equation when you are knowing the roots. I am solving second and third examples at a time. So, let alpha is equal to 3 and beta is equal to minus 10. This side, alpha is equal to half and beta is equal to minus half. First, we have to find alpha plus beta is equal to 3 plus minus 10 is equal to 3 minus 10 is equal to minus 7. Simple algebraic sums. Here it will be alpha plus beta is equal to half plus minus half is equal to half minus half is equal to 0. So in the both examples we got the value of alpha plus beta. Now we will find alpha into beta is equal to 3 into minus 10 is equal to minus 30. This is the value of alpha into beta. Here alpha into beta is equal to half into minus half is equal to minus 1 upon 4. These operational fractions were taught in 7th standard, exercise number 39 it was. So you must know these things. When denominator is same, we multiplied the denominator and we got the answer. So we got alpha plus beta. The standard equation is, when you know the roots, the standard equation is, it is x square minus alpha plus beta into x plus alpha into beta is equal to 0. Same this side, since x square minus alpha plus beta x plus alpha into beta is equal to 0. Now the final, putting the values. Here x square is x square minus into bracket alpha plus beta is minus 7 x plus alpha into beta is minus 30 is equal to 0. Therefore x square plus 7x minus 30 is equal to 0 is the required equation. Now this side it is x square minus alpha plus beta is 0, x plus alpha into beta is 1 minus 4, minus 1 upon 4 is equal to 0. So therefore x square minus 0x minus 1 by 4 is equal to 0 is the required equation. This way, when we get roots, we can form the quadratic equation. In previous exercise, equation was given, we went for the roots. Equations were given there, and we found the roots. Here they have given the roots and we have formed the equations. This is fourth example in the same question. Two roots are 2 minus root 5 and 2 plus root 5. These are the conjugate pairs you have studied in 9th standard. If your teacher had taught you surds are very important in algebra. Whenever you go in any standard, any college, you will face these surds, and operation on surds are very important. If your teachers have taught you nicely, you will understand very nicely. These things are conjugate pairs. If your teachers are taking pain for surds, then you should thank them. These are conjugate pair. Surds, same surds having different sign, opposite sign, are called conjugate pair. So here alpha is equal to 2 minus root 5 and beta is equal to 2 plus root 5. Okay. Now we have to find alpha plus beta is equal to 2 minus root 5 plus 2 plus root 5, which is equal to, opening the brackets, 2 minus root 5 plus 2 plus root 5. These two get cancelled because they are opposites, and the answer is 4. So alpha plus beta is equal to 4. Now alpha into beta is equal to 2 minus root 5 and 2 plus root 5. Have a look carefully. It is a plus b, a minus b. A minus b and a plus b. So identity will be formed. What identity? It will be 2 square minus root 5 the whole square. A square minus b square. So 4, 2 square is 4 minus root 5 square is 5. It is minus 1. So alpha into beta is minus 1. We got the value of alpha plus beta and alpha into beta. Remember the operation on surds and identities. The examples will be easy. So now, since x square minus alpha plus beta, x plus alpha into beta is equal to 0. So x square minus into bracket 4x plus into bracket minus 1 is equal to 0. Therefore, x square minus 4x minus 1 is equal to 0 is the required answer. A required equation. This finishes our question number 4. This finishes our question number 4. Now, applications in word examples of roots alpha and beta. Let us see. We are in the question number 5 of exercise 2.5. Here they have given equation is x square minus 4kx, x square minus 4kx plus k plus 3 is equal to 0. And what they have said, sum of, condition is sum of roots is equal to 2 double of 2 into product of sum roots, product of roots. if you read the example, it's like a puzzle. See, find k if sum of roots of quadratic equation x square minus 4kx plus k plus 3 is equal to 0 is double their product. So, by playing with words, they have confused you. Don't get confused. What they say, this is the equation, and for this equation, the sum of roots is double of their products. Sum of roots is double of their products. Very simple. Alpha plus beta is equal to 2 into alpha into beta. Very simple. So, first of all, we have to comparing with ax square plus bx plus c is equal to 0. A is 1, b is equal to minus 4k, and c is equal to k plus 3. Question is like this. There is an equation where equation x square minus 4kx plus k plus 3, and condition is sum of the roots is equal to double the product of roots. Find k, find value of k. So, first we compare and we got the value of a plus b, a, b and c, and now we are using relations, that is alpha plus beta is equal to minus b upon a. Here b is minus 4k, therefore minus into bracket minus 4k upon a is 1. So alpha plus beta is 4k. Now alpha into beta is equal to c upon a, which is equal to k plus 3 upon 1 is equal to k plus 3. Let be 1, 2. Statement number 1 and 2. I am explaining once again. Comparing the given equation with this standard equation, we got A, B, C. Condition is sum of the roots of this equation are 2 into product of roots. So, this is sum of roots, alpha plus beta is equal to 2 into alpha into beta. Given 3. We found value of alpha plus beta by using the coefficients. We found value of alpha into beta by using the coefficients. And now they have given sum of roots is equal to double the product of roots. Sum of roots is equal to double the products of roots. Means alpha plus beta, that is 4k, is equal to 2 into bracket alpha into beta, that is k plus 3. Therefore, from 1 and 2 and 3, from 1 to 3, alpha plus beta, alpha into beta, which is put in the given condition, we got this one. So it is 4k is equal to 2k plus 6. Therefore, 4k minus 2k is equal to 6. So therefore, 2k is equal to 6 and k is equal to 6 upon 2 is equal to 3, and the final answer is k is equal to 3. Once again I am explaining. Equation was given and condition was given. So condition is clear. Sum of the roots is double the product of roots. Sum of roots is double the products of roots. We compare the given equation with standard equation. We got the value of a, b, c. We got the value of a, b, c. A is 1, b is minus 4k, and c is k plus 3. Alpha plus beta we found by using the coefficients minus b upon a. Minus b is 4 minus 4k. So minus 4k upon 1 is 4k. Alpha into beta is c upon a. So we use c upon a. C is k plus 3 upon 1. So it is k. Now the condition is sum of roots is equal to 2 into product of roots. Sum of roots is equal to 2 into products of roots. We used it, we solved it, and we got the final answer k is equal to 3. These type of examples you may feel difficult if you will not practice nicely and neatly with 100% efforts. These examples are easy, they will give you marks, full marks, but hard work is necessary in the practicing. So I am starting 6th example of exercise 2.5. The equation is y square minus 2y minus 7 is equal to 0. Y square minus 2y minus 7 is equal to 0. And now they have given alpha and beta are the roots. Alpha and beta are the roots. Find alpha square beta square and alpha cube and minus beta cube. Find alpha square plus beta square and alpha cube minus beta cube. Apparently it looks very easy, but you must know the procedure thoroughly and you know the identities thoroughly of 8th standard. Then and then only you can solve these examples. What is that? First of all, we are comparing the given equation with our standard equation. It is a routine process, and finding the value of a, b and c. See, a is 1, b is minus 2 and c is minus 7. As usually we found the values of a, b, c. After that, using the relation between roots and coefficients, using the relation between roots and coefficient, alpha plus beta is nothing but minus b upon a. Alpha plus beta is nothing but minus b upon a. So that is minus 2 upon a 1. Minus b upon a. So that is minus 2 upon 1, which is equal to 2. Which is equal to 2. And then alpha into beta is equal to c upon a. C is minus 7 and a is 1. So minus 7 upon 1 is minus 7. So now alpha square plus beta square value we knew. It's not like that, अरे इधर alpha beta मिला like the square 4 हो गया. No, that's not so easy. Now come to identities of 8th standard. A plus b the whole square, a plus b the whole square is equal to a square plus 2ab plus b square. Correct? A plus b the whole square is equal to a square plus 2ab plus b square. Correct? Now, alpha square plus beta square means a square plus b square. I have written there alpha plus beta. You remind your olden days, alpha plus beta converted into a plus b the whole square. Sorry, a square plus b square means a plus b into a plus b. Here it is alpha square plus beta square. So alpha plus beta and alpha plus beta, product of 2. So it will be alpha into alpha, alpha square, alpha into beta, alpha beta, beta into alpha, alpha beta, and beta into beta, beta square. In other words, we can say the value of these two identities, even though they are looking very different, they are same. See, alpha plus beta the whole square is alpha square plus 2 alpha beta plus beta square, and alpha square plus beta square is also alpha square plus 2 alpha beta plus beta square. Means these two identities have same expansion. So these two identities are same. I need alpha square plus beta square this side. So I sent this to this side, 2 alpha beta to this side, and value of this alpha square plus 2 alpha beta plus beta square is taken as this one. This one. Those two identities have same value. So I shown their values same. I kept alpha square beta square to LHS, and I have sent this 2 alpha beta to right hand side. And one more thing, instead of writing alpha square plus 2 alpha beta plus beta square, I have taken the compact size of an identity, alpha plus beta square. So we need alpha square beta square. It is alpha plus beta the whole square minus 2 alpha beta. So alpha plus beta is 2 from 1 and 2. Alpha plus beta is 2 and alpha into beta is minus 7. We have put the values. So it is 4 minus 2 into minus 7. So it is 4 minus 14. 4 plus 14 is equal to 18. So alpha plus square plus beta square is 18. This is the answer of first part of the example. In cubic also we are going to do the same thing, but I will use the shortcut. I am not going to explain these things. These are in 8th standard. So I explain this. For next part, I am going to put the values directly. Okay? We will see the next part. So the remaining part of the example is finding the value of alpha cube plus beta cube. I have written here alpha cube plus beta cube is equal to alpha plus beta the whole cube minus 3 alpha beta plus into bracket alpha plus beta. To get this idea, just I explained you the square identities. Similarly, I have written here a plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. A plus b the whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. And the value of a plus b the whole cube, nothing but this is a cube plus b cube. A cube plus b cube is also same. The value of a cube plus b cube is also same. A cube plus 3a square b plus 3ab square plus b cube. By using these two, just we use the square relations. Similarly, we are using cubic relations. We use square relations and now we are using cubic relations. We got this one. Previously we got square relation. Now we got cubic relation. So alpha cube plus beta cube is nothing but alpha plus beta the whole cube minus 3ab. Minus 3ab means 3 alpha beta into bracket alpha plus beta. So alpha cube plus beta cube is equal to alpha plus beta cube means 2 cube from 1 and 2. From 1 and 2. 3 is 3. Alpha into beta is minus 7 and this alpha plus beta is 2. So a 2 cube is 8 minus 3 into bracket 3 into bracket minus 7 into 2, that is minus 14. Minus 14. So this minus 3 into minus 14 is actually minus 42, and after opening the bracket it is 8 plus 42 is equal to 50. So the final answer of alpha cube plus beta cube is 50. Don't forget these identities. Don't forget those square identities. Use and practice them again and again. You will get the difference between, similarities between cubic and square identities. These are same, a plus b the whole cube and a cube plus b cube. Similarly, that time we use a plus b the whole square and a square plus b square. So both are same. So this is sixth example of exercise 2.5. Clear? 101% these type of examples you have to practice for your exam. You will get full marks. The last example of exercise 2.5 is seventh one. What they have given? They have given the equations and they have given one unknown k and they have used the condition. The equations have roots real and equal. Real and equal. The given equation has got roots real and equal. When the roots are real and equal, when delta is 0, delta is equal to 0. Discriminant is equal to 0. B square minus 4ac is equal to 0. They have given the condition, the roots are real and equal. When the roots are real and equal, you know when delta is 0. When delta is 0, when b square minus 4ac is 0, that is discriminant is 0. So this is the base of these examples. So let us find here या फिर compare with ax square plus bx plus c is equal to 0. A is equal to 3, b is equal to k, and c is equal to 12. We have to find the value of discriminant delta. So delta is equal to b square minus 4ac is equal to k square, b square means k square, minus 4 into bracket 3 into 12, c is 12. So k square minus 4 into bracket 36, which is equal to k square minus 144. Correct? But delta is 0, roots are real and equal. Therefore, delta is equal to 0, 1 and 2. From 1 and 2, k square minus 144 is equal to 0. Delta is equal to 0. Therefore, k square minus 12 square is equal to 0. So it is nothing but k minus 12 is equal to 0, or k plus 12 is equal to 0. So the final answer, k is equal to 12 or k is equal to minus 12. Minus 12 cannot be accepted because the values are real. The values are real. You can see the everywhere you will get two values where you have to reject the 0 value. We will do it another way. You will get it very nicely. We will use this place also. So, question is 3y square plus ky is equal to 0. Correct? And we had got this one. Delta is equal to k square minus 144. Since delta is equal to 0, roots are real and equal. Roots are real and equal. Therefore, k square minus 144 is equal to 0. K square minus 144 is equal to 0. It is nothing but our simple values, a square minus b square. Therefore, this part was not coming in the camera, so I have solved it again. K square minus 12 square is equal to 0. Therefore, k minus 12 is equal to 0, or k plus 12 is equal to 0. Therefore, k is equal to 12 and k is equal to minus 12. K is equal to 12 and k is equal to minus 12. Here the value of k is either 12 or minus 12. Therefore, k is equal to 12 or k is equal to minus 12. Remember, why we have taken delta is equal to 0? The roots are real and equal. The relation between roots and value of delta, the relation between value of roots and delta, that is discrimination, that is b square minus 4ac. It's very tedious one. They are not given directly, they are given hidden hint that equation has roots real and equal, means the answer of b square minus 4ac must be equal to 0. Correct?